Okay. Where I'm going with this is, suppose your money is compounded not daily, but every instant. Then you have instantaneous compounding. And then what it is going to be equal with instantaneous compounding is this. See, the more times it's compounded per year, the closer you get to instantaneous compounding. And then you're switching to an instantaneous growth model. And then the formula for an instantaneous growth model is this. V equals A times the mathematical constant E to the RT power. And if it's growing instantaneously at 5%, then at the end of 1 year, it would be this. 1,000 times E to the 0.05 times 1. Or just 1,000 times E to the 0.05 power. Okay. So you need to have a calculator that will calculate E to any power. So on my calculator, what I do is I put in the interest rate, 0.05, and then I hit E to the X. And E raised to the 0.05 power is what? Does anybody, can anybody tell me? Because you're going to need to know how to do this. What is E to the 0.05? Heather, 1.05. Let's carry it out just a little bit further. 127,110. Then if you just move the decimal over 3 places, this becomes 105,1.27. And what's interesting about this, it's the same, Matthew, as what you gave me earlier for daily compounding. The difference between instantaneous compounding and daily compounding is the same to the nearest penny in this case. Now, if you carried it out, the digits out further, you would find that this one is a little bit, this number, if you carried the digits out further, would be a little bit greater than this. Okay, but rounding off, they're actually the same. So compounding daily is almost the same as compounding instantaneously.
What is E again?
E is the mathematical constant. But Bernard, I'm glad you asked that, because I'm going to give a rigorous definition of what E is now. E is this. E is the limit of 1 plus 1 over m raised to the mth power as m goes to infinity. Okay. And it's very similar to what we just did. For example, the only difference is instead of a 1 here, we had the interest rate. But otherwise, it's exactly the same. Let me show you. Let's just call this part right here, this thing in brackets, f of m. Let that be f of m. F of m is defined to be this. 1 plus 1 over m raised to the mth power. If m equals 1, what does this equal? F of m. Yeah, it's 1 plus 1 is 2 to the 1 power is 2. Okay. What is f of 2? M equals 2. Well, this would be 1 plus 1/2 squared. Or 1.5 squared, 2.25. Okay. What is, let me just jump ahead, what is m equals 4? Then f of m, or f of 4, is 1 plus 1/4 raised to the 4th power. 1.25 raised to the 4th power is approximately 2.44. Oh, let's jump ahead. What is m to the 365th power? Well, it's 1 plus 1 over 365 raised to the 365 power. And this is what I was giving you earlier. This is equal to 2.7145. Now, in the limit, as m goes to infinity, f of m approaches e. And e is approximately this. Let me just give the first 5 digits. E is approximately this, 2.71828. Okay. That's an approximation for E. Actually, you know, it goes on forever, that decimal, and it doesn't repeat. It's an irrational number. But it's approximately that. Now, every once in a while, they have these contests. Who can approximate E to the greatest precision? And some people are amazing, can get it out to like 100 decimal places or more. They've just memorized it. But it goes on forever. So theoretically, you could just go on all day and you would never get it exactly right. Okay. But the exact, Bernard, the exact definition of E would be this. It's the limit of this thing right here. 1 plus 1 over m to the mth power as m goes to infinity. Okay. And that's what you use when you're doing continuous compounding. Okay. Let me just give you the general formula. If you have continuous growth, continuous instantaneous growth, then the future value of money is given by this formula. V equals A times E to the RT. Where again, V is the future value of money. A is the value right now, times 0, the present. E is that mathematical constant. R is the continuously compounded interest rate. R is the continuously compounded interest rate per year. And T is time measured. We're assuming it's measured in years. So this is the formula. Okay, you ought to be able to do simple calculations using this formula.